In this video, we will be graphing linear functions, absolute value functions, and piecewise functions. All right, starting off with good old linear functions. In my mind, I'm thinking about the model y equals mx plus b, aka slope-intercept form. That reminds me that the 4 is the y-intercept, so I could put my first dot right here, and then the slope, -3, I could think of it as -3 over 1. So rise over run becomes down 3, right 1. So down 3, right 1, repeat, repeat, repeat. All right, and going to the left, I can go up 3, left 1. So that shows me exactly where the line should be graphed. And then just graph the line. Okay. So that's what number 1 looks like. Now number 2, same type of deal, but this is not already in slope-intercept form. So we need to rewrite this to get the y by itself. So I'm going to do that here in the margin. So I have 2x minus 3y is equal to 9. Your first move will be to subtract 2x from both sides like this. And then that's going to give you -3y is equal to -2x plus 9. And now we're going to divide everything by -3. So that will give us y equals positive 2/3 x minus 3. A negative divided by a negative is a positive. Now that we have slope-intercept form, we can graph it. So -3 is the y-intercept, which is here. Slope 2 over 3 means up 2, right 3. All right, so up 2, right 3. And I can repeat this pattern to the left by going down to left 3. So this is where the line should be graphed. So number 2 should look like this. Now, notice that number 1 and 2 are linear, and I can tell that because there's no absolute value symbol. So looking at number 3 and 4, a common mistake is some students will try to draw this also as a straight line, or some students will try to draw number 1 and 2 as a V. But it is absolute value functions that form some type of a V shape. And it'll be an upward facing V if it's positive. Okay, so this one should be like an upward facing V. Or it will be a downward facing, okay, that's a horrible V. Should I do that, redo that? It will be a downward facing V if it's negative. So see that negative? I know this one will be a downward facing V. Now the parent function y equals absolute value of x sort of looks like this, with its vertex at the origin, and then it forms a V like that. But the +2 and the -3 will move this vertex. So the +2 will move us left 2, and the -3 will move us down 3. So I know that's the opposite of what this looks like. This one's normal. So left 2, down 3. So here we go. Left 2, down 3. This should be the vertex of this V, like that point right there. Now, since there is no number in front to change the slope, it will just go up 1 and right 1 from here, like this. I'm just going up 1, right 1. And because I know it's absolute value and it's going to form this V, I'm just going to do the mirror image by going up 1, left 1. All right, so there you go. So this is what the graph should look like for number 3. Number 4 is very similar. This -1 will move us to the right 1 and then up 4. So right 1, up 4 is going to put us here. Now remember, because it's negative, I know this is a downward facing V. this number in the front is going to change the slope. So the first thing I'm going to do is draw the right-hand side of this graph, starting at the vertex, and I will go down to right 1 because of the negative 2. So down to right 1, repeat, repeat, repeat. Now, because I know it's a V shape, then I will just draw the other side symmetrically by going down to left 1, and then just repeat, repeat, repeat. So this shows you what this graph is going to look like. So that's it for number 4. All right, now finally we're going to graph a couple of piecewise functions. So let's just do one piece at a time. So this top piece is y equals x plus 1. So let's graph that. Now that's a regular old linear equation. So we have our y-intercept of 1. So we would start off putting a dot at 1. And then the slope is 1 over 1. So I could go up 1 over 1 from here. Now, there are two ways of doing this. So I'm doing this without a calculator right now. But there's a way of doing it using a calculator that I'm going to show right after this. So stick around and watch the other method and decide which one you like best. All right, so this is what this piece would look like if I were graphing the whole thing. But I'm not graphing the whole thing. I'm graphing the part where the x values are less than negative 2. Now you might think I would go straight to negative 3 because it says less than, but you'd be wrong. You have to put the circle at negative 2. So look, here's negative 2, and at negative 2 on the line, we are here. Now notice I'm making this an open circle because that's how I show that it can't actually be negative 2. It has to be less than. But that way I don't skip all the decimals in between negative 2 and negative 3. Now, so less than, that means x value is going to the left. Okay, so I need to be on this side. So that's how I know to draw in this part of the graph. All right, and if you put a bunch of dots like I did, then you better have done it in pencil because you need to erase. All right, so that's the first piece of the piecewise function. Now here comes the second piece. So y equals negative 2x plus 1. So again, I'm going to go to plus 1 because that's my y-intercept, so on the y-axis. My slope of negative 2 means down to right 1. So I'm going to do that. All right, down to right 1 over and over again. And I'm going to continue that pattern to the left by going up to left 1. So we'll just continue the same pattern. All right, so that's the entire line. But I don't want the entire line. This piece only happens when the x values are greater than or equal to negative 2. So again, this negative 2 tells you where to start. So look for which one of these dots is sitting at an x value of negative 2. Hopefully you can see that it's this one. This dot right here has an x value of negative 2. Okay, so that's going to be the end point of this segment. Of course, because I want x values that are greater than or equal to 2, I want to take x values that go to the right from here. So that's going to be this portion of the graph, though. All right, I know that was super crooked. You know, I'm going to try that one more time. It's really hard to draw straight lines on an electronic, with an electronic pen because there's a lot of friction and my hand just kind of jerks along as it responds to the friction. I was doing pretty well to the end, but I don't have time to redo that. Just erase these extra points, and that's it. That's how you do it. Any questions? I always have to resist the urge to ask any questions. This is a video. You can't ask me the questions back. So I hope you didn't have any questions. Now let's go ahead and do, oh wait, I said I was going to show you how to do this on the calculator. So let's do that. Boom! This time I'm going to do the same problem using my TI-30 XS Multiview. which I love very much. So looking back at this, if I want to graph the first piece, y equals x plus 1, then on my calculator, I can go to the table function, clear out anything that's in there, and just type in x plus 1. So x plus 1, enter. Now I want to start at, I know this number that's part of my domain restriction, this is going to end up being the endpoint of this piece of the graph. So I want to start at the endpoint, start at -2. So -2. Enter, 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 enter. So that means my endpoint is going to be -2, -1. So here I go. I'm going to go to -2, -1, and put an open circle because this is not included, not equal to, so we have to leave it open. Now what? So we want x values that are less than -2. So on the calculator, if I want to go less than -2, I'm going to have to scroll up because -3 is less than, -4 is less than. These are all values that are less than -2. So let's just plot these points. So -3, comma, -2. Okay, so -3, comma, -2. How about -4, -3? -4, -3. And how about -5, -4? -5, -4. Now that's plenty to see the pattern, so I'll just repeat the pattern after that. Okay, and you can see this is the exact same graph that we got the last time. Now let's do the same thing again with the second piece. Y equals -2x plus 1. So again, table feature, clear it out, -2x plus 1. Yeah. Hit enter. Again, I want to start at -2 because I know that's going to be the endpoint. Okay, so start at -2. Enter, 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 enter. So this is the endpoint, -2, 5. So -2, 5. And go ahead and make a closed circle there because this will be included. We want x values greater than or equal to -2. So that includes this. Now I want the rest of my x values to be greater than -2. So the numbers greater than -2 on the calculator will be below. So I'm talking about these values. -1, 3, -1, 3. Okay, so here we are, -1, 3. 0, 1. 1, -1. Okay, now I can see the pattern happening. It's going down to right 1. So once I see the pattern, I can just continue the pattern. Okay, so this graph is going to look like this. And that's how you can draw these with the help of a TI-30XS multiview or other scientific calculator. All right, let's move on to number 6, which is another piecewise function. This one we will not bother using a calculator because it's so simple. Let's see, when I look at this first piece, if I put my y equals in front of this like I normally do, it makes this simple little equation, y equals -2. That little tiny equation represents a horizontal line. Okay, y equals -2 is a horizontal line at -2, like this. All right, but we must respect the domain restrictions. All right, we only want the part where the x values are less than 1. Again, that doesn't mean go to 0. You still start at 1. Just put an open circle to show that you can't equal 1. All right, there's no or equal to sign. But you can be less than 1, which takes you to the left. All right, that way you're not skipping the decimals between 1 and 0. So that's what that piece of the graph should look like. Let's do it 2 more times. Y equals 0 is a horizontal line at 0, like this. This is the line y equals 0. But we've got these domain restrictions, and you should think between. We want x values between 1 and 3. So along this line, here's 1 and here's 3. And so here we go between 1 and 3. Now, 1 is less than or equal to x, so we'll make this a closed circle. All right, x is less than 3, not equal to 3, so we'll leave that an open circle. So that's what the middle piece of this graph should look like. And finally, if we do the piece y equals 2, that is a horizontal line at 2. But looking at the domain restriction, we want x values to be greater than or equal to 3. So here's an x value of 3, and it says, equal to 3, so we'll include this point. And then comes the greater than part, which is to the right. So that's what that piece should look like. And we're done. So this is what the graph, this piecewise function should look like overall. And that's going to be the end of this video. On my next video, which is continuing this sort of review of absolute value and piecewise functions, let's take a little preview. We will answer these questions, all right, matching these piecewise functions with the graph. Okay, so do a little analysis, do some evaluating, and then finally we'll write a piecewise function for this graph of a piecewise function. All that coming up on the next video. So stay tuned and meet me there.